Hi everyone, welcome you all. So, I hope you are learning SQL and database concept day by day. And in this series, we are going to discuss relational algebra today. Okay, so what is relational algebra? Actually, what are the operations which can perform on a databases? This is called a relational algebra, and the main operations which are prescribed by CBSE for your syllabus are selection, projection, union, and Cartesian product. So let us discuss one by one what are these. Okay, so select operation, when we select rows on the basis of certain condition, then it is said to be a select operation. Let's go ahead and read the definition from this PDF. Selection is relational algebra returning those tuples oblique records in a relation that fulfill a condition, right? And it is represented by sigma, right? And here is a relation. You can see we have a student relation and we have certain columns here: admission number, name, class, section, and average. Suppose we say sigma a, so all the rows having section as a will be returned as a subset or query result, right? And this subset is called your sigma operation, right? So 101 Anu and 483 Usha A, right? So these will be two output for the sigma. For example, here is this thing: class is equals to 12 S, or you can say we can write like this: sigma class in bracket A. So all the rows having section A will be returned, right? For example, we can write somewhat like this: sigma, it should be a symbol sigma, right? I'm not able to write in notepad, you can understand it's a sigma. And here I'm going to use section is equals to A, and the output will be all the rows having section as A. So you can write expression somewhat like this. So here is a sigma symbol. Okay, so hope you understood this selection operation. The next is projection, where we select certain columns, or from the table we are selecting only two columns. So here is called select sorry projection operation. Projection is a relational algebra returns those column in a relation that gives in the attribute list. Okay, so it is represented by pi, then you can specify number of columns from the table student, right? So it will return a value. The next is union. For union, we have to merge two tables, right? So you can see we have a student 1 table and student 2 table, and remember, for union both the tables should be um, compatible with each other, or you can say that name, number, and type of column must be same, right? So roll number matches with the roll number and name matches with the name. Okay, if you have similar structure of two tables, then you can use a union, or it is represented by a symbol union. Okay, so now you can see we have uh, like this: pi roll number name student 1 union pi roll number name student 2, and this will return a result having all the values from the two tables. Okay, now Uh, notice one thing, it is represented by sigma here, but union is represented by a union operator, which is U operator. You can say capital U, right? And the next is Cartesian product. This is really very important. This is also called a cross product, and it can be easily achieved when you do not use a join in a join query, right? Let us read this. SQL joins are used to relate information in different tables. It combines fields from two or more tables by comparing value of a common columns. A join condition is a part of a SQL query that retrieves row from two or more tables. Right, we have discussed this in class 11th as well. What is join? And if join condition is omitted or it is invalid, then join operation will result in a Cartesian product. Cartesian product is a binary operation and is denoted by x. Cartesian product returns a number of rows equal to number of rows in the first table multiplied by number of rows in the second table. So this statement is really very critical here to here, because it gives you how many rows it will return when we have a Cartesian product. And similarly, this statement, the next statement, is also really very important, which will reveal how many column we will get when we have a cross product. So it will give you a sum of the two participating tables column, right? So for example, if we have two table in table 1, two column in a table 1 and two column in table 2, then it will result into 4. Or if we have 2 and 3 here, then it will result into 5. So let's see, here you can see we have a product and having 3 columns. In customer we have 4 columns. Then if we try to have a cross product between these two, so result, you can see 1 2 3 4, and if you count, this will be 7. Let's count it: 1 2 3 4 5 6 and 7. Why it is so? Because we have 3 columns from the product table and 4 column from the customer table. Now notice the number of rows: 4 here, and I think it's 5. 4 into 5 is equals to 20. So total number row in this result will be 20. Let's count it. So 1 2 3 4 5, 5 plus 5 10, 10 plus 5 is equals to 15, and 15 plus 5 is equals to 20, right? So total number of rows returned by the cross product will be 20, right? So here is the calculation. Now let us see how these rows are formed. Notice product number 1 1 1. So this is the first record in our product table, and this is copied 5 times. Okay, let's check it out. So this is 111 computer and 50,000. This is the first record. And if you notice, customer number 101 Kavita Delhi and 333 is the first record in the customer table, and similarly 201 is matched with 111, and then this is matched with 301. This is also same record is matched with 401, and same record is matched with 501. So we have a complete combination of all the records from product table to customer table. Similarly, second record from the product table is matched with all the records in a customer table. Third record matched with all the records in the product table. Similarly, and so on. So that's why it is giving you 20. 4 multiplied by 5 is equals to 20. So this is really very important, and there is always a question which asks for to calculate a degree and cardinality of the table. So cardinality will be number of rows in a result or in a table, then it is said to be a cardinality. So if you are going to calculate a cardinality of a two table, then you have to find a product of the rows, and that will be your cardinality for the product. Okay, so let us see what we have revised in these 4 days, right? So we have defined a relation was a simple table which is a combination of rows and columns. And domain is a different or atomic values in our table. For example, if we have a section A B C D and these are repeated multiple times, but in database we are going to store a particular value in one place. For example, A is stored no matter how many times we have used A in my table, but it is stored in as a one value or atomic value in that particular domain. Okay, the next we have learned a tuple, and this tuple is a number of rows. Sorry, actually a row or an individual row in a table is called a tuple. Attribute, a column in a table is called a attribute. Primary key, primary key is used to uniquely identify each table in a relation, so that we can identify each value and we can use it to delete, search, or modify it. Candidate keys, all the keys which can serve as a primary key but we haven't chosen yet, then these all keys are called candidate keys. Alternate keys, obviously the keys which are left out after making a primary key are called alternate keys. Then we have a different type of statements, DDL statements, data definition language, used to describe your data or used to create or alter your schema objects, just like table. If you want to create it, then we have to use a create table command, or if you want to modify this table, then you are going to use a alter table command, right? So DML statement is used to manipulate the data. For example, if you are going to insert a table, then insert a row, then you are going to use a insert statement, right? And then we have string data types, numeric data type. We have already discussed it. There are char and varchar in MySQL. Char is fixed length and varchar is a variable character length data type which can store text for alphanumeric values. And then next we have a numeric type. In numeric type we have a number, int, integer, float, and decimal in MySQL. So we will be using these data types, and we can specify precision and scale there also. Precision is total number of digits, and scale is the number of decimal points. Date is a different data type, and though in MySQL we have a time as well. And then we have discussed these operations, four operations in Boolean algebra, that is selection. When we select certain number of records on the basis of values in particular column, then it is said to be a selection, and it is represented by sigma. Similarly, we have a projection. In projection we select certain columns, then it is said to be a project operation, and it is represented by pi. And then we have discussed a union is represented by u, and for this we have two tables with a similar structure. We can um, add these values in the union operation. Duplicate recall will be automatically removed from the resultant table. And then finally we have discussed the cross or Cartesian product. This is really very important. Do learn this, because many times this question is in your CBSE board examinations. So SQL joins are forget about this definition. Actually cross product is formed when we multiply each row with the rows in another table, forming multiplication of rows, and then we call it a Cartesian product. And number of rows formed by the Cartesian product or in Cartesian product is number of rows in table 1 multiplied by number of rows in table 2, and the columns are simply added, right? So this is all about our first chapter, that is concept of database. And from tomorrow we are going to learn a new chapter that is called SQL, or we will be working with SQL, right? So till then, goodbye and have a nice day. Bye bye.